today I'll start permutation combinations. So the starting class I want to explain the main important basic rules of permutations and combinations. So in permutation combinations the most important basic rules are two rules. One is fundamental principle of addition and the other is fundamental principle of multiplication. So what is the meaning of fundamental principle of addition and fundamental principle of multiplication? Now we are going to see. Now you see, for example, three departments like maths, physics, and what chemistry. So here, let us suppose in maths we have four cores or four subjects, okay, and here in physics we have three, and chemistry here we have two courses. You have to select one course from these three, maths maybe or physics or maybe chemistry. So how many ways you can choose one course from these three courses? Means totally the total number of courses in the college is 4 plus 3 7 plus 2 9 courses available for a student, out of which one course should be selected. So how many ways it can be done? Simply 9 ways. Okay, means from maths you can select any one course, or you see, or I say or one course from physics. So it can be done in how many ways? 3 ways. You can choose that subject, that course from the physics department 3 ways. Okay, say if I say P1 is course name and P2 is the other and P3 is the third course. So you may select P1 or P2 or P3. So it can be done in 3 ways. Or from chemistry still you have two choices. So any one of the chemistry course you can select. So therefore total number of ways will become what? 9. So what we did here? We did the addition. This department has 4 choices. In this department we have 3 choices. In this department we have 2 choices. So totally we have 4 plus 3 plus 2. So indirectly we are adding. If you calculate department wise, then again you add, you will get the 9 choices. So 9 ways you can select. So actually this is nothing but we are using here fundamental principle of addition. So what is that? How we will define the fundamental principle of addition? Now you see. Let us suppose there is a work which can be finished in m ways. Okay, the same work can be finished in a different case n ways. The same work, so the same job. Okay, we can finish that in m ways in a separate case, and in another case the same job can be finished in n ways. So how many ways that job can be done? We say that it is m plus n ways. Okay, now we will see how we will apply this fundamental principle of addition. Okay, once again you see, if there is a job, okay, there is a job which can be finished in m ways. A job can be finished in how many ways? M ways. And the same job can be finished in a different case. Let us suppose in a different case it can be finished in n ways. Now the question is how many ways that job can be finished. So here we are saying the total job is finished in m ways in a separate situation, and the same job is finished in n ways in another different situation. So how many ways you can do the same job? Okay, for that what we will do, we will add m plus n ways. So here we will add how many ways that job can be finished, we will add, because of the same job is finished in a different situations. Now for example, I'll give an example. Suppose a student wants to join in a coaching institute for mathematics subject. A student wants to join in a coaching institute for a mathematics subjects, and for him the available timings are in the morning. Either he wants to go in the morning or in the evening. Okay, he wants to join, and three coaching institutes are offering in the morning, and 4 coaching institutes are offering the mathematics course in the evening. So how many choices that student has, we have to count. So what is the job? What is the job? Selection of a coaching institute, either in the morning or in the evening. So once you observe here, the two different situations we have in the morning, and later we are saying or in the evening. So either he can join any one of the institute in the morning, or he can join any one of the institute in the evening. Okay, so in the morning he has 3 choices, in the evening he has 4 choices. So total number of choices, if you want to count, how many? 3 plus 4, that equals to 7 ways. So what I did here, we used addition. We added the number of ways 3 plus 4. Why? Because the same job can be finished in the morning session, or the same job can be finished in the evening session. So there are, whenever you use the word are, then we have to add. So you remember, so whenever a job can be finished, okay, in m ways, in n ways, in a different situations, mutually exclusive situations, there is no common, okay, in that case we have to add. So this is called fundamental principle of addition. Now, after giving the definition of fundamental principle of multiplication, I'll come back to this. Okay, so there may be some confusion still we have in the principle of addition. And now I am going to clarify with an example after defining what is a fundamental principle of multiplication. Now you see fundamental principle of multiplication. Suppose now I'll take again a course. Okay, a course consists of 3 subjects. A student has to take maths as well as physics as well as chemistry. So a course consists of 3 subjects, maths and what I am using now, and physics and chemistry. The student has to select one subject from each of these MPC, maths, physics and what, chemistry. One subject he has to select. So let us suppose in maths we have algebra, okay, and calculus. Suppose we have 3, calculus and geometry. Like this we have in physics something like thermodynamics, kinematics and optics. Okay, here we have 2, organic chemistry and what, physical chemistry 2. So out of these courses he has to select one from each group, from maths 1, from physics 1 and from chemistry 1. So now how many possibilities, how many choices that student has? Out of that I'll give you one simple example. Okay, one is what, algebra he is going to select from maths, and kinematics he is going to select from physics, and organic chemistry he is going to select, okay, from chemistry. So this is one choice for a student. Now the course consists, his course consists of algebra, kinematics and what, the other is what, the other third chemistry subject is what, organic chemistry. So this is one choice. Like this the student has how many choices, we have to calculate. So now you see, for maths how many choices he has, algebra, calculus, geometry. So he has 3 choices. And for physics how many he has, again 3 choices. And for chemistry how many he has, 2 choices. So are we going to add these choices? Are we going to write 3 plus 3 plus 2? Obviously it is wrong, because of here he has to select 3 subjects from this one, from this one and from this one. So how many ways it can be done? We are not going to use fundamental principle of addition. Okay, now you see why, because for algebra he may selected thermodynamics with organic. With algebra he may select thermodynamics with physics. So with algebra only we have how many, 2 choices. Now again with calculus, thermodynamics, organic, physics. With calculus, kinematics, organic, physics. Like this here we are going to get so many combinations for that course. Okay, now what I'll do, first I'll concentrate of selection of only maths and physics, then I'll come back to how to select the chemistry. Now physics, see algebra, so see the combinations, algebra with thermodynamics a T, and algebra with kinematics a K, algebra with optics a O. Now you observe with A we have how many combinations, 3 combinations. Now with calculus how many combinations will come again, calculus with thermodynamics, calculus with kinematics, calculus with optics. So 3 more, 3 more with calculus. So with calculus we have 3 combinations, and with geometry again thermodynamics, with geometry kinematics, with geometry optics. So with geometry also we are having how many? 3 choices. So totally with A3 plus with C3 plus with G3. So totally how many combinations? 3 plus 3 plus 3. How many times we are adding 3? 3 times we are adding 3. For example, here if I take optics and one more subject, if you want to select any another subject, the fourth subject, if I select, what happens? Again one more 3 will come. One more 3 will come with this. Okay. So electrostatistics, if I take E, electrostatistics, so what happens? What happens? One more 3 will come with algebra E, with calculus E, with geometry with E. So one more 3 will come. So how many combinations? 3 plus 3 plus 3. So 4 times of 3. So what is happening? We are multiplying 3 4 times. So 3 into 4. 3 into 4. Now 3 into 4 means how much? 12 combinations we are having. But that 12 for each combination, we have organic. You can attach that combination with organic. You can attach with the combination physics. 1 minute. So I'll clear this. So you may get a confusion, right? So now you see. Okay. So actually I took one more extra subject here, E. So how many combinations I have? 3 here, 4 here. So I got totally 12 combinations. 12 combinations up to only maths and physics, but still work is not finished because of the course consists of 3 subjects: maths, physics, chemistry. So still there is a work to do. What is that work? Selection of one chemistry, where we have already 12 combinations. So out of 12 combinations, for example, if I say C1 is the one combination, maybe that is algebra and kinematics. So one combination is this. So now with C1 you can take organic. Now with C1 you can take what? In physical chemistry, organic chemistry or physical chemistry with a C1. With a C1. So for each combination we have 2. For 2 combinations we have one more 2. So 2 times 2. For third combination we have 2 more. So that is 3 times 2, 4 times 2, 5 times 2. How many times 2? Because of 12 combinations are there. So 12 times 2, that equals to 24. Okay. Here we are doing the multiplication, not addition. Right? But now you see, I'll clarify when we can do the fundamental, when we can use the fundamental principle of addition. Now for example, only I want to select one subject, any one subject. So from maths or from physics or from chemistry. So I'm using or. So whenever you say or, okay, whenever you say or, whenever you want to do the work in different cases separately, it can be done in 3 ways, or it can be done in 4 ways, or it can be done in 2 ways. So totally how many ways? 3 plus 4 plus 2. That is the addition. But here not, that is the job. Here the job is not selecting one subject. Here the job is selecting 3 subjects, maths, not R, maths and physics and chemistry. So in such type of situations, what we will do, we use the fundamental principle of multiplication. Means whenever you want to do some finite number of jobs one by one, okay. So whenever you want to perform a work or a job one by one, and then in that case you have to multiply. So I'll now write a formal definition for that. Let us suppose there is a job 1, which can be finished, which can be done in m ways, and job 2, which can be done in n ways. Then job 1 and job 2 one by one in consecutively can be finished in how many ways? M into n ways. So you can extend the idea for 3 jobs also. If one job is there which can be finished in m ways, the other job can be finished in n ways, the third job can be finished in p ways, then the 3 jobs one by one consecutively can be done in how many ways? M into n into p ways. So remember, practically while you are solving the problems, we split a problem into some sub jobs. First job, how many ways you can do? Second job, how many ways you can do? Third job, how many ways you can do? Later we will multiply them to get the final result. Now I'll give you an example of that example. Okay. In this example, I'll use both fundamental principle of addition and fundamental principle of multiplication. We are going to use both the rules at a time in a single problem. Okay, now here you can see there will be no confusion after seeing this example. You won't have any confusion in applying the fundamental principle of addition and fundamental principle of multiplication. Okay, now you see 0 comma 1 comma 2 3 4 7. Now here you count how many digits given to us. 1 2 3 4 5 6. 6 digits given to us. Now using these 6 digits, you have to form a 3-digited even number. Now see the condition what we want to form. We have to form 3-digited. We have to form 3-digited even number. Okay, 3-digited even number. Now so therefore, whenever you want to construct a number of 3 digits which is even. Now when a number is said to be even, if the last digit, the digit in the units place is even digit, obviously that will become an even number. For example, 234 is an even number because the 4 is even digit. 128 is an even number because of the last digit is even. So whenever the last digit is even, obviously that number will be divisible by 2. A number is divisible by 2, it is called even number. Now here what are the choices we have to form an even number? Okay, so here 0 1 2 3 4 7 here we have, out of which 2 is the even digit, 0 is the even digit and 4 is the even digit. So you can use maybe here 0 or 2 or 4. There we have 3 choices. But there is a problem. Whenever you use 2 here, if 0 comes here, whenever you use 2 here, if 0 comes here, once again I am repeating, whenever you use 2 here, if 0 comes here, what happens? That will become 0 3 4 something like this. But it is not 3-digited number because of 0 3 4. Actually it is what? 34. We will say it is a 2-digited number. So there will be a problem in filling these digits whenever 0 is present. So I do this problem in a different manner. What is that? What I will do, because of there is a problem with 0. Okay, there is a problem with 0. I'll divide this problem into 2 cases. Okay, so the main job, okay, in different situations. I am doing the job in different situations. What are that situations? If you use 2 comma 4 here, one case, or if you use 0 here. Okay, what I told just now, for the last place, units place, here we have 3 choices. May you can use 0, may you can use 2, may you can use 4. So using 0, separate case I am doing, using 2 comma 4, the other case in a different situation. Okay, that's the other situation. Now I'll come to this first case. So what I did here, I placed this 0 in the units place. So how many ways? There is no choices other than this. Therefore there is only one way, because of 0 is the only choice for you. That is the case we are taking. That is a different situation. That is situation we are taking, one way. Okay. Now because of we used 0, considering that used digit cannot be used. Okay, repetition is not allowed. So considering this one, what I will do, second place I will fill up now. For the second place, because of already used 0, you are already used 0. So therefore how many choices you have? Maybe 1, maybe 2, 3, 4 and 5 choices. So sorry. So out of these 5 digits, any one digit you can use here. So how many choices we have? How many ways you can fill this place? 1, 2, 3, 4, 5 ways. So it can be done in 5 ways. Now I'll ask a question. Is work finished? Is the job finished? Not yet. Still there is a one more work we have to do, that is filling the last place, hundreds place. Now because of 0 you used already, and one of the digit you used from these 5. So how many digits left? 4. So there are how many ways? 4 ways. There are 4 choices we have. So now the job is finished. Whenever you do this one and this one, also this one, then the job is finished. So you want to do these 3 works one by one. So therefore there comes fundamental principle of multiplication. So what we have to do? 4 into 5 into 1, that is equal to 20 ways. 20 ways it can be finished. Now, this case. Here, any one of the digit 2 or 4 you can use. So, how many ways it can be filled up? 2 ways. 2 ways for the last place, units place. May you can use 2 or you can use 4. Therefore, 2 ways. Now, remember, you can use 2 or you can use 4, any one of the digit. After using one digit, one more digit will be there. Okay, one more digit will be there after filling here. So, now before filling this place, I will concentrate this place first, because of still we have a 0. Still we have a 0 on our list because of 1 of 2 comma 4 used. So, if you used 2, what are the digits left with us? If you used 2, 4, 4, 7, 3, 1, 0. So, there is a 0. So, there is a problem. That is why first I will fill up the hundreds place, starting place. One digit used, out of 1, 2, 3, 4, 5, 6, out of 6, one digit used. How many choices we have? 5. Actually 5, in fact 5, but 0 we cannot use. 0 we cannot use. One digit used, left with us 5. Out of 5 you cannot place 0 here, it will become 2 digited number. So, it is wrong, not actually 5 choices. How many choices? 4 choices, because of one digit used here and the digit 0 cannot be used. That is why we have 4 ways. Now, what happened? Here one digit placed and one digit arranged here. So, 2 digits we used already. And what is our consideration? Used digit cannot be used and 2 digits used. So, how many choices left for this middle place? Again 4 ways. Now, the job is finished. So, whenever you perform one by one all these 3 jobs, then the job will be finished. So, therefore, all we need this job and this job and this job, and so therefore fundamental principle of multiplication. So, 2 ways into 4 ways into 4 ways. So, 4 to the 16, 16 to the 32 ways the job can be finished in this case. Okay, whenever you want to place 2 or 4 in the units place. Now, you see one number is 20, the other number is 32. Here you see this job can be finished. The job of what? What is the job? What is the work? What is that work? Forming a 3-digited even number. Forming a 3-digited even number. So, this total job is finished in the case whenever it is place containing 0. The same job in a different situation can be finished in how many ways? 32. So, the job is finished in this case or in this case. So, here whenever a job is finished in a different cases, okay, entirely into different cases, you have to add. Okay, it's not like it should be finished and that should be finished, then main job is finished. Wrong, because of whenever in the units place 0, forming 3-digited is completed. Here also in units place 2 or form, forming 3-digited is completed. So, forming 3-digited number is completed, entire work is finished here. And here also entire work is finished. Entire work is finished in 2 different situations, and there is no common. There is no common in these two. They are totally different. So, therefore,